And I wanted to put together a video today to talk about this concept of delegate factories and Autofac. And I'll show you an example of that. I'm just going to jump over to an Autofac module here. Actually, I should show you the classes that actually leverage it. But essentially, a delegate factory and Autofac is a mechanism that you can use to construct a type using this delegate, and essentially Autofac, because if you're using Autofac registrations, it's able to figure out that like if you can see that this constructor here takes in one parameter and my factory doesn't take in any parameters, Autofac through the registration is able to figure out that when someone calls invoke on this factory method, that it should go figure out behind the scenes that it needs one of these dependencies, and it wires it up. So there's a couple of reasons why these can be helpful. A really good example is if you had something like, I'm just going to put this on a new line here. If you wanted to do like string cool name and pass that in, you might be able to use Autofac to register one of these dependencies. So I have them. It's something called a string provider. It's a pattern I use. And that might be, like a single instance kind of thing. You register it once and whatever. There's no state that's changing. So great. And it's every time you make one of these view models, it will always take in the same instance. However, you might want to be able to make this view model and pass in the second parameter, and it's always going to be potentially something different every time you construct it. So a way that you can get around that is you could do something like this, where as long as you have access to this factory method, all that you need to do is provide this second parameter, right? And Autofac knows, based on the registration, that it will go figure out this other parameter for you. So it's kind of cool because it gives you this hybrid approach of being able to use some of this Autofac magic to do this resolution for you, but at the same time giving you some customization for how you're constructing things. So that's one reason why they can be kind of helpful. The other reason, I'm just undoing all that. The other reason they can be kind of helpful is that I have situations where for a lot of the things I use Autofac for, I'm constructing them once. They kind of exist for the lifetime of the application or for the lifetime of some part of the application, and that's great. But there's sometimes these instances where I need to make like little, call them like one-off instances, and they're short-lived. But when I do that, I want a new instance every time. So I'm not creating it at the beginning of the application. I need to delay the creation of it, and I probably want to make more new instances of it. So in this particular example that we're looking at, that's exactly why I have a factory delegate method here for this thing. So the situation that I came across today when I was refactoring some code for the application we're creating in Xamarin Forms was that I have something that shows a pop-up to the user. And that pop-up has a view, and it has a view model associated with it. But every time I want to show this pop-up, I want to make a new view and a new view model. So that's kind of the thing that I'm working through here. But the reality was that this string provider is always going to be the same instance. It's really just almost like a constants type of class. It just holds some strings for me. Later, I'll have them localized and all that kind of stuff. But for now, it's really just a few properties with constant strings. So it's always the same. However, I do need to create new instances of this view model and pass them into a new instance of the view as well. Right? Okay, so that's why I have a factory method here. I mentioned as I was talking through that I also need new instances of the view. So I need to use a delegate method or a delegate factory like this on the view as well. So I'm going to jump to that. And what you'll see here, let's ignore this constructor for now. The constructor that I'm more interested in is this one here. It takes in a view model and a toast service. So here's another example where the toast service in the constructor, it will always be the same service for the lifetime of the application. However, because we're making new view models when we go to show this pop-up, I need to pass in the new instance of the view model. So because this pop-up page itself is not created at the beginning of the lifetime of the application, it's created later, and I want to make new instances of it, it will also need a new instance of the view model to go along with it. So I needed to be able to say, since I'm making a new view model, I'm going to pass that in here on this factory. And like I just explained previously, this toast service, I'll highlight that, it does exist for the lifetime of the application. So Autofac will handle going to resolve that dependency for us, which is great. Okay, so the code that wants to use that, or maybe I'll show you what the module looks like first, specifically for those two things. So when you're registering things for these factory methods, you just use, I'm just going to move them down here so that they're separate so you can see them, because there's some other stuff on here that I'll come back to. These two things right here that just have register type, that's all you need along with your delegate methods. So I'm going to jump into the definition of these. We've already seen them, but right, so this first class we looked at, and you can see it has this delegate factory method here. Important to note, because this is going to be part of the topic of the conversation today, is the return type must, as far as I know, I haven't seen a way around this, so if someone knows, please let me know. The return type of this has to match your type that you're working with here, right? So I cannot do this and have everything work. I can't return the interface off the factory, which is what I want to talk about today. So I'm going to go back to the module and we'll look at the pop-up one just to kind of prove. Oops. So there's two spots here because it has the code behind and the designer. But you can see this is the other one that had this delegate factory, right? And you can see the return type is also the same as the class. Cool. So that's what the module looks like, specifically for registering things with these factory methods. Now I want to look at the part of the code that's going to use that, and that is my Navigator class. So I have this pattern that for showing pop-ups or navigating through the application, I have this thing called a Navigator, or a pattern, I guess, that I use, and it's just responsible for handling, basically setting up the state that you want to show on the screen that you're about to navigate to, or the pop-up you're about to show, gets that all prepared, and then either navigates you there or puts the pop-up up for the user. So I do have some code commented out because I'm going to come back to that. But what we're looking at here, we have two factories that we wanted to deal with. I'm showing a hybrid of the two things I want to talk about. But essentially, sort of, I don't want to call it the problem, but the thing I didn't really like is that when you go to use these factory methods with Autofac, your new type, so my choose location navigator, one of the dependencies that will get passed in through Autofac is this delegate method, right? And the other one, I'll just quickly change to show you, is this one. Oops. I have the wrong name. Choose location pop-up page. There we go. Naming's fun. Right, so Autofac would figure out, because of those type registrations, that it could pass in these two factories, which is great. And then this choose location navigator would receive that when we go to register. So if I go back to the module, you can see I register this type, choose location navigator. So when we resolve it later, like I said, Autofac will know how to pass these things in for us, which is great, because now we can go to use them later. Okay, so to use these factory methods, it's literally just a delegate, right? So the one had no parameters, which you can see here, right? We're making the view model, it took no parameters. So if I jump to that method, right, you can see no parameters on here at all. I'm just going to change up some of this code here so we can, I kind of left it as a hybrid, like I said, so because I could illustrate some things better. But so if we wanted to make the view, I'm just going to put some extra W's on there so we don't get IntelliSense getting all upset. You also invoke this one, but it takes one parameter, which is the view model, right? And just to prove it, so this is the pop-up factory. If I jump to that, just like we saw earlier, it does take this one view model. Cool. Okay, so what's the problem? Why am I making this video? What am I here to complain about today? And really, it's nothing that crazy. It's just that I am not a huge fan of when I'm trying to separate out implementations from interfaces and things like that. I'm not a huge fan that this class, Choose Location Navigator, now has concrete dependencies on these two other classes. Okay, so really it's a pretty minor thing, and I can imagine in more complex applications or systems that this could become a bigger problem. But it started, like, I saw it creeping in here, and I was like, I wonder if I can address this. So the thing I don't like is that this class, you can tell, like, strictly if it's not totally jumping out to you, just look at the color of the things that are in Visual Studio here. So these are two interfaces, right? I have an eye pop-up navigation interface. Literally, it's an interface, and what I'm saying by defining it like this is this class does not care about the implementation of this, right? So someone later on can go change part of the application to register a different implementation of eye pop-up navigation, and this class should not care. The same thing with this eye event tracker, right? Right now in the application, there's only one implementation of it, right? But I'm by defining this dependency here as strictly by the interface, I'm saying I don't care what the implementation is. As long as it meets this API, this class will be happy. However, we get to these two things, and for the most part, like, this factory delegate is just a signature that says, like, I don't care, but it could, right? It lets us leak in some sneaky things, I guess is what I could say. And I'm going to try to show you an example of why I don't like that, and then how I moved around it. So the first thing is, like, as I said, you can clearly see that because these are not interfaces here, I now have a dependency on these two types, these two concrete types explicitly. Not a huge fan of that. So that was the first thing that I was like, like, if I can avoid that, I'd like to. And I'm going to show you with a bit of a contrived example just why I don't like that. So right now, if we were using this properly, let me see this thing down here. I'm going to comment out the rest of this code because we'll come back to it. But this is essentially what it was trying to do for the most part. And it's not page, I guess I can name this a little bit nicer now. So what we were doing was making a new view model, passing into a new view, and then telling our pop-up navigation interface, like, it says push async, which is essentially like push this pop-up to the top of the pop-up stack so the user will see it. And true is just so that it animates. So really something simple here. So why is it a problem? Well, you can't, it's not going to show in the recording, but when I hover over view model here, the type is, and it's not going to be as obvious because you can't see it, but it says choose location view model, which sounds right. However, the fact that it says choose location view model and not I choose location view model means that this thing here, we have knowledge of the concrete type that's being used. Okay, so our code now has access to a concrete type for view model. And if I hover over view again, you can't see it in the recording, but it says choose location pop-up page. It is not the interface of it, and it's not, this one's a bad example because this other pop-up navigation thing here, not something I wrote, and it does actually require a concrete type. However, it requires a base type, and this pop-up factory that we're dealing with here actually gives us a more specific type than we need to know about. So why is that bad? Okay. It's again, this is going to feel a little bit contrived, but this is one of those things that if you know about it and you can prevent it, you can prevent some situations in your code base where you're like, oh crap, like we started to get a bit of spaghetti code in this one spot. Now we have a couple of dependencies that are leaked through, and like refactoring it's going to be tricky. And so let's kind of step through that. I'm going to go to this choose location view model. And for the most part, there's a bunch of stuff on here. I'm going to collapse it all so it's a little easier to see all at once. And I'll expand it. So we have a bunch of properties. It has a latitude, a longitude, the center, a formatted distance that we can show in the UI, just the numeric distance, a command. Like there's a bunch of stuff on here. And for the most part, these should match what's on the interface. Okay, so if I jump to the interface, you can see that a lot of those properties, ideally all of them that are public, should be met on this interface. So what's tricky about that is that I could come through here and I could go public string nix sneaky, if I could spell nix sneaky property, right? Now I have this thing on here, and what that lets us do on this navigator is we can actually access it here, which isn't like, if you're reading this or like reading this code or you're watching this video, you might say, okay, well, that's really not bad. Like, who cares? And, in this example, it isn't bad. There's nothing really wrong with this. It's just the fact that this class, choose location navigator, now has knowledge about a concrete type. That's really all I'm trying to get at, is it has knowledge of a concrete type. And when I'm designing, classes in systems, I try to separate that as much as possible. I don't, unless they're like super simple, what we call like a DTO or a data transfer object, that has like, it might hold like a string for someone or a couple of numbers or something really simple, that's not mutated. Unless it's something that simple, I really don't like things having knowledge about other concrete implementations. So the fact that I have that here bothers me. Again, really simple example, pretty contrived. However, I do think that there are examples in real code bases where this kind of thing happens, where you have a class that depends on another concrete implementation of another class. And you can run into some situations where sort of some of these details are leaking through and people have access to things that maybe aren't on, a public API like an interface. Okay, so that's the thing I wanted to overcome. How did I do it? Well, you probably saw a little bit earlier before I was trying to delete some of this code, but what I had done, and for sure, like, again, reading through this code or watching this video, you might go, oh, this feels like overkill. Like, I don't want to have to do that. Totally get it. I somewhat enjoy taking patterns to a bit of an extreme, because to me, it's kind of cool to just like, to work through some constraints and be like, if I really want to avoid, this class depending on other concrete classes, how can I do it? It's not to say it's always the best thing to do. It might be overkill in some cases. Totally get it. So I'm not trying to push like some agenda like that, but how could you get around it? So you saw that I removed those two delegate factories and I put these other interfaces in place. So what I've actually done was I made dedicated classes and dedicated interfaces for those factories. So if we jump to the view model one, this view model one, literally what I'm doing is I'm taking a specific factory, so it has one single purpose and it's going to construct things. And I've moved that dependency I didn't like strictly into this factory. So now it's in one spot that's dedicated to creating things. So to me, I talk about this, with my colleagues and stuff like that, about like, if you're, it's going to sound a bit exaggerated, but when you're dealing with like crappy code or a crappy pattern you don't like, the more that you can kind of hide and move that, air quotes, crappy code or crappy pattern into one small spot and isolate it, the better. The more that you have a crappy pattern or something you don't like that's like spreading out through your code base, you're kind of creating this future problem to work through. So what I've done is I've moved, this problem or this pattern I don't like of a concrete type, right? Depending on another concrete type, I've moved that to one spot, and then I made a dedicated interface for basically constructing these. Okay, and if I go to the other one, it's very much the same. All right, so I'm going back into this other new factory. I tried to, and it didn't like the shortcut. Go to definition. Oh, not what I want. Go to the implementation. There we go. So it looks similar, right? Where I have a concrete type depends on another concrete type, and then a dedicated method to creating things. So this example was the one I was saying I'm not a huge fan of it because it still returns another concrete type. However, this is because I'm interfacing with another third-party library that requires that I deal with these classes. There's certainly ways around isolating that problem or pattern I don't like. I don't like using the word problem. It's not really a problem. But isolating that pattern in a different way. However, for what I wanted to accomplish, it was really the focus here. So highlighting these lines, right? I have a specific type that depends on one other specific type, and then working through that. So if I go back to my Navigator, you can see that there's a bit more code here because that other Delegate factory that I was showing, like I had it reduced a little bit, so it wasn't a totally fair comparison. But essentially, it looks like this resembles it a lot closer with this other little event tracker thing that I had left out. So it looks mostly like that. Now the cool thing here is that did I leave it on the view model? Nick's sneaky property, right? It's still here, right? So if I tried to use that on the view model now, it's not there. And the reason it's not there is because this factory, again, you can't see the IntelliSense as I'm hovering over stuff, but if I go to this method, it returns the interface. It does not return the concrete type for us. So when we go to use it on this line here, I only have the interface. I don't know that this is a concrete type that is choose location view model. I only know it's the interface for it, right? So because this property here was never put onto the interface, we can't access it, which means that we can't kind of bleed through or leak like implementation details that weren't meant to be exposed. If we really wanted it to be exposed, we should probably put it on the interface or part of the public API that other things can see. So that's sort of my argument for why I like this approach better. It means that like I said, I isolated where I don't like that pattern, right? So these dedicated factory classes, and then my calling code doesn't have to deal with those patterns that I don't like. So if I jump back to the module that we looked at right in the beginning, I'm just going to undo a bunch of this to show the organization of the code a little bit better for how I liked it. What I've done was I put the pop-up page with its corresponding factory. I did the view model with its corresponding factory, right? I'm still using register type on these ones with nothing else because this will let Autofac wire up that delegate factory for us for each of these, this one and this one. And those delegate factories get passed into these concrete types here, respectively, because each one depends on the factory of these other things. And then these are registered by their implemented interfaces. And if we jump into the Navigator, you can see that I'm only requiring the interfaces, right? So if we think back to right near the start of this video, I was saying that one of the things I did not like was writing code that had a concrete type depending on more concrete types. And now that's gone away, at least here. I've isolated the pattern I didn't like to a smaller, more specific spot. So that's, I think, mostly what I wanted to talk about today. So if you found yourself working with these delegate factories in Autofac, and you weren't a fan of those concrete types depending on each other, this is a pattern I've started to adopt to work around that. Um, don't want to say that this is something you have to do, or that it's the only way that you could accomplish this. This is what I've come up with and started using, and I do like it. I like that I don't have these concrete types leaking through in here when I'm creating these things. Um, I could imagine there's situations where you do want to be able to do that. In a particular class, that you want to modify some other class you have knowledge about. I can't think of a good example, but maybe you want to be able to do that, and then maybe you return that um, as an interface to someone else. So you're kind of masking the fact that you had some extra knowledge about the class you were dealing with to return an interface of it. So I suppose there's probably some cool sneaky things you could do that way, but um, yeah, this was my approach for trying to minimize that sneaky behavior. So thanks. That was just a short video, but that's just what I wanted to touch on today.